Good evening, everybody. So we are going to discuss uh, Fourier series, topic from mathematical physics. Okay, and this is actually itself an independent chapter that is asked in different exams, and also it is very helpful when you solve partial differential equations. Okay, so uh, ये जो फुरियर सीरीज है इसका एक्चुअली दो टाइप का एप्लीकेशन है. एक तो सपोज यू हैव अ फंक्शन, एंड बाय फंक्शन आई मीन दैट सपोज यू हैव अ सिग्नल. सो व्हाट टाइप ऑफ frequencies are playing or what type of frequencies are present in that signal cannot be known by seeing the function itself. So if you write it in the form of Fourier series, then you are able to know that first harmonics, second harmonics, third harmonics, all of those frequencies can be seen from the Fourier series. So that is the one part. Second part is while solving the partial differential equation like Laplace equation in electromagnetics, Schrodinger equation in quantum mechanics, or many different wave equations in electromagnetics and mechanics. So while solving these equations, Fourier series becomes very important. Without that, you can't apply the boundary conditions. Okay, so this is the chapter that we are going to study. This is very interesting chapter if you see it from the physical point of view. ऐसे तो purely mathematical concept है, but if you see it physics wise, it becomes very important. So that's why electrical engineers and physicists, they use lot of Fourier series. Okay, so what is Fourier series? So actually, like Taylor series, this is also an infinite series. Okay, in general, in some case it may have finite number of terms. So in general, ये कैसी series होगी? In general, it will be an infinite series. And what we do is we write a function. We write a function in the form of their harmonics. Okay, so this makes it a very important analytical tool. Okay, so at the end I will tell you actually Fourier series for the continuous case becomes Fourier transformation. Okay, so that I will tell you finally. So that's why it becomes a very important analytical tool, and also it is used to solve partial differential equations like Laplace equation and Schrodinger equation. Okay, Laplace equation and Schrodinger equation. So you can see its importance, and I will be following this chapter from this very nice book. You can see Kreyszig. Okay, so for this chapter, I will be following this book, Erwin Kreyszig. And this time we have decided that we will be studying little portions from the textbook as under the guidance of teachers like us. And so I will be giving you, and a folder is shared, you can see in the group, and there is this soft copy of this book. From there we can discuss how much to read, what are the important questions. So sometimes I will give homework from that. Okay, so what is the outline of this chapter? In this chapter I will discuss a full series I will discuss half series. Okay. I will discuss Parseval's identity. And finally, I will discuss complex Fourier series. Okay. So this will be the outline of the chapter. So whenever it will be required, I will be giving the outline. Whenever it is not required, I won't give. Okay. जिसमें chapter में depth में जाके ही पता चलना है. So उसमें we will not discuss much of the outline. But this is a small chapter. I have given you the outline. And let us start now. Anything you would like to share? किसी को कुछ बताना है या पूछना है? I can erase this.
Yes,
Are
sir.
you? So आपको थोड़ा सा सुना हुआ है Fourier series? Some of you?
Yes, sir.
Yes. Yes, sir.
Okay. So what is your name? Among those who have joined us today, somebody would like to tell what is?
Sir, Bharat here from.
Yeah, Bharat.
Yes,
What
sir.
is?
So,
What is Fourier series?
sir, किसी भी फंक्शन को चाहे वो कंटिन्यूअस हो या नॉन कंटिन्यूअस हो, उसको हम उनकी हार्मोनिक्स में लिख सकते हैं.
अच्छा, ये बड़ी इंपॉर्टेंट बात इन्होंने बोल दी कि कंटिन्यूअस हो या फिर फाइनाइट नंबर ऑफ डिसकंटिन्यूटीज. ओके, ठीक है ना? फाइनाइट नंबर ऑफ डिसकंटिन्यूटीज, आई मीन डिसकंटिन्यूटीज का पता हो, तो देन वी कैन राइट इट इन द फॉर्म ऑफ Fourier series. So this also you can write. Yes, very good.
Yes, sir.
So actually I would say कि सबको Fourier series पता है पहले से. ठीक है, इस चैप्टर को मैं ऐसे ही शुरू करता हूँ. That we all know the Fourier series, just the name may be new. Okay, because we have seen it from class 10th. How? Like अगर किसी को एक फंक्शन दे दिया जाए fx is equal to suppose sin square x. Okay, suppose I gave you a function fx is equal to sin square x, then you know your high school formula that it can be written as half minus 1 by 2 cos of 2x. Yes or no?
Yes.
This
Yes, sir.
formula you have seen, everybody?
Yes, sir.
Okay. And also, if somebody gives you fx is equal to cos square x, then also you know you can write it in the form of 1 by 2 plus 1 by 2 cos of 2x. Or if somebody gives you sine of cube x and cos of cube x, just give me the formula quickly. What will be the sine cube x? Equal to, so you know sine of 3x
3 by 4
is 3 sine x minus 4 sine cube x. Okay, so what will be the sine cube x is equal to? It will become 3 by 4 sine of x minus 1 by 4 sine of 3x. So I can write it as 3 by 4 sine of x minus 1 by 4 sine of 3x. Similarly, what will happen to cos cube x?
3 by 4 cos x
3 by 4 cos x
plus 1 by 4 cos 3x.
plus 1 by 4 cos 3x. Is this correct? Everybody? Okay.
Yes, sir.
So you can see that without knowing what is Fourier series, what we were doing actually, please see it carefully, ध्यान से देखो. Sin square x को मैं यहाँ पे cos 0x या इसको चेंज करूं, cos ऑफ 0x एंड cos ऑफ 2x के फॉर्म में लिख लिया, राइट। cos स्क्वायर x को भी cos ऑफ 0x, cos ऑफ 0x, प्लीज ऑफ योर माइक somebody, किसी का माइक ऑन है, ऑफ कर लो। रामित, so cos of 0x plus cos of 2x, and similarly sin cube x is written as sin of x and sin of 3x. So these are actually harmonics word क्यों यूज किया जाता है, let me explain you, कि अगर सपोज ये होता sin square omega t, suppose this was sin square omega t, तो इस केस में what would have happened, ये हो जाता हाफ माइनस half cos 2 omega t. So this is telling the presence of frequencies. So here it is a DC term because zero frequency, and here it is 2 omega. From here you can't see what type of frequencies are present because this may be a complicated function of omega t. So this is the second harmonics. This is the second harmonic. So that's why I was telling you कि सिग्नल के अंदर क्या छुपा हुआ है, once you write it in the form of Fourier series, that comes out, so you can analyze that frequency. तो कोई suppose there is some complicated displacement of time, you write it in the form of Fourier series, so you will see what are the combination of frequencies with which वो जो displacement है वो oscillate कर रहा है, okay, so that is why. और सपोज सम ट्रांसमिशन सिग्नल है, सम कम्युनिकेशन सिग्नल है, तो उसको जब तुम फुरियर सीरीज में लिखते हो तो यू गेट टू नो व्हाट टाइप ऑफ फ्रीक्वेंसीज आर इन्वॉल्व. सो दिस इज लाइक विदाउट गोइंग इनटू द फुरियर सीरीज, आई हैव रिटन द फुरियर सीरीज बिकॉज आपको ये फॉर्मूले हाई स्कूल से पता है, एंड you will wonder to know that these are the previous year questions of JAM also. Okay, so they have been asked at different times in JAM. One more thing I would like to explain you. If you have left hand side the function which is even, so you know functions can be categorized in three forms: even function, odd function, neither even nor odd function, right? फंक्शन को हम तीन फॉर्म में कैटेगराइज कर सकते हैं: इवन फंक्शन, ऑड फंक्शन, नाइदर इवन नॉर ऑड फंक्शन. सो व्हाट इज हैपनिंग, जो इवन फंक्शन है वो हमेशा इवन फंक्शंस के ही फॉर्म में लिखा जाएगा. सो साइन स्क्वायर एक्स वाज इवन फंक्शन, so that's why it is written in the form of cosine, which is even function. Cosine was even function, that's why it is written in the form of cosine, which is even function. Sine function is odd function, sine cube is also odd, so that's why here odd functions are involved, which is sine. And cos cube x is even function, that's why even functions are involved. So obviously because बीच में एक equal to का साइन है, इसका मतलब लेफ्ट साइड इक्वल टू राइट हैंड साइड है, तो अगर लेफ्ट इवन है तो राइट में भी इवन फंक्शन ही होगा. So this is one very very important thing. And you know everybody that even function is when f of minus x is equal to f of x. Odd function is when f of minus x is equal to minus f of x. और अगर ये दोनों काम नहीं कर रहा है, so that means your function is neither even nor odd. Okay, so with this much of information, now we can enter into the actual formulation of Fourier series. So ये देखो questions आपने, without the knowledge of what is Fourier series, we have written these functions. So actually high school में जो बड़ी बड़ी ट्रिग्नोमेट्रिक आइडेंटिटीज हम सॉल्व कर रहे थे, और अगर राइट हैंड साइड में ऐसे फंक्शंस आ गए जिसमें सिर्फ x 2x 3x टाइप के फंक्शंस हैं, sin of x 2x 3x, cos of x 2x 3x, so incidentally that was Fourier series. Okay, तो Now let us come to the point. So if I have a function fx and I write it in this form, summation n is equal to 0 to infinity an cos of nx plus bn sine of nx, right? This is the function. So if you open it, how it will look like? It will become a naught plus a1 cos of x plus a2 cos of 2x plus dash 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 plus b1 sine of x plus b2 sine of 2x plus dash dash dash. So this is known as Fourier series. Okay, so for a function fx, this is known as Fourier series. And हम लोग सबसे पहले फुल सीरीज पढ़ेंगे. ध्यान से देखना इस डिवीजन को, इट इज वेरी इंपॉर्टेंट. And full series we can study between the range minus pi to pi or 0 to 2 pi or minus L to L, okay, or 0 to 2L. So this will be all, this all belongs, all these range belongs to the Fourier series, which will be known as full series. Okay, अभी हाफ सीरीज के बारे में बात नहीं करते हैं. अभी right now let us only talk about the full series, and this is the full series. Okay, now जैसे टेलर सीरीज होती है कि you write a function in the form of x minus x naught square, x minus x naught cube. So that is टेलर सीरीज. उसी तरह से साइन और कोसाइन के फॉर्म में जब हम किसी फंक्शन को लिख देते हैं, if we write a function in the form of sine and cosine, that is known as the Fourier series. Now अगर मुझे an और bn और a naught इसकी वैल्यू पता चल जाए, we are done. So हम क्या करेंगे, इस फंक्शन को ऐसे लिख लेते हैं, fx is equal to a naught को बाहर लिख लेते हैं प्लस summation n is equal to 1 to infinity an cos nx plus bn sine of nx. Okay, so you can see ये टर्म अलग हो गया, इसमें कहीं भी nx है नहीं. So इसलिए इसको अलग से हम we call it as DC term, which is obviously coming from, you know, analysis of the signals by electrical engineers. So this is known as DC term. DC term why? Because there is no oscillation. If I put x is equal to omega t, suppose कोई function हो, so this will be independent of the oscillation. So that's why this will be called DC term or constant term. Okay. Now if we know the values of a naught, an and bn, अगर मुझे a naught, an और bn की वैल्यू पता चल जाए, तो इसका मतलब है कि हमारा काम हो गया, बिकॉज हमें fx लिखना था. fx finally came into the form of a naught, an and bn. If we can write the values of a naught, an and bn, our job is done. Okay, so let us try to write it. So this is very interesting method which we use in partial differential equation also, and this derivation is very important. Please see it carefully. Suppose मैं सबसे पहले I am seeing it for the range minus pi to pi. Okay, so what I will do to calculate this, calculate the values, is like this. Please see. So जैसे ये चलता हुआ जाएगा, so somewhere, so suppose it is a1, then dash dash dash, then it will be some an cos nx and plus dash dash dash, right? It will be like this. And similarly it will be plus plus bn sin nx and plus dash dash dash, right? समझ आ रहा है भाई?
Yes, sir.
Yes, sir.
So now what we do is, first is to calculate a naught. Just integrate both sides from minus pi to pi fx dx. So first term will be minus pi to pi fx dx, and similarly this integral will go to each and every term, right? But all of them will become zero. You can see that all of them will become zero. चाहे वो cos हो x, cos nx, sin x, sin nx, everyone will become zero.
Sir,
ये
A naught,
राइट साइड में एक जीरो लिखना.
Sorry, ये मैंने लिख दिया, इसको पहला टर्म था ना, a naught dx. Yes. Okay. So this will become a naught into 2 pi. Right? So a naught will come out to be 1 by 2 pi integral minus pi to pi, okay, and fx and dx. So this is the first term, the DC term that was calculated. Any problem in this? Any doubt?
No.
Is it clear? Yeah.
Yes, sir.
So now please see, we will note down all of this. A naught ho gaya hamara. Now suppose again I want to calculate the value of an. Please see this. An I want to calculate. So to calculate an, what I will do, I will multiply both sides by cos of nx so that this an survives. And this will become, everywhere this will be multiplied, right? Dash dash dash, everywhere it will be multiplied. It will become an cos square nx and plus every term will be multiplied. And now again, I will integrate it from minus pi to pi fx cos of nx and dx. And this will be multiplied to each and every term, and they all will be killed in the integration minus pi to pi. So only this will survive. It will become an minus pi to pi cos square nx and dx, right? Okay. Now this is even function. So you can write it as 2 times an minus pi to pi, right? Sorry. 2 times an 0 to pi cos of square nx dx. Okay. And you can use this integration always, cos square or sin square. It is just upper limit by 2. So it will become 2 times an into upper limit by 2. Because cos square nx hai, you can write it as 1 plus cos 2 nx by 2. And then when you integrate, cos will become sin and it will be 0 at pi and minus pi. And 1 will survive. It will become pi. So it will become pi by 2. Okay. So this will become a n pi. So what will be the value of an? You can see the value of an will be minus pi to pi 1 over pi and fx cos of nx and dx. Please see this. Yes?
Yes, sir.
Okay. Is it okay?
Yes, sir.
yes, sir.
So इसी तरह से similarly you can multiply both sides by sin nx and you will get the value of Bn. So what values we have got? So we had fx is equal to summation n is equal to 0 to infinity an cos of nx plus bn sine of nx, right? This was our Fourier series. And what values we have received? A naught we have received as 1 by 2 pi integral minus pi to pi fx and dx. An we have received 1 by pi integral minus pi to pi, okay? And fx cos of nx and dx, सही है ना? And bn we have received as 1 by pi integral minus pi to pi fx sine of nx and dx. So these are the coefficients. These are known as Fourier coefficients. Fourier coefficients. Okay. So this was very, very important to understand. Now just you can see here it is 1 by 2 pi, 1 by pi, 1 by pi. तो काफी अच्छा होता अगर ये 2 pi के बजाय 1 by pi हो जाता, राइट? तो ये जो कॉस्मेटिक है आप कर सकते हो थोड़ा सा कि इस 2 को यहां अडॉप्ट कर लो पहले ही, a नॉट बाई 2 प्लस समेशन n इज इक्वल टू 1 टू इंफिनिटी. ये फिर से लिख लो सीरीज, ये बड़ी इंपॉर्टेंट बात है जो बता रहा हूं. cos of nx प्लस bn sin of nx. ओके, नाउ अगर ये 2 यहां कर लोगे तो व्हेन यू विल कैलकुलेट यू विल गेट ओनली पाई. So now it is much better, 1 by pi, 1 by pi, 1 by pi. Okay. But the first term became this a naught by 2. So please understand, Fourier series is a unique series in a given range and with the given function. So ये जो first term होगा ये same होगा. First term will be same in both cases. Just the value of a naught will change. मान लो कि first term की value आ रही है 4. So in the first type of Fourier series, when the first term was a naught, that value will be 4. And in this type of series, that value will become, a naught value will become
8.
8, right? Because 8 by 2 will again become 4.
Yes, sir.
Okay. So इस बात का आपको बहुत अच्छे से ध्यान रखना है कि ये जो Fourier series है, that is always given in the question that the Fourier series is defined as this. And then they ask questions. Okay. So you have to be very, very careful that whether it is a naught by 2 or it is a naught. And if nothing is given, only Fourier series is asked, then you can take any one of that because Fourier series is unique. So you will get the first term always same. तो यहाँ पे एक एग्जाम्पल लिख लो ताकि हमेशा याद रहे. एग्जाम्पल कि अगर फर्स्ट टर्म सपोज 4 है तो फर्स्ट केस में a नॉट 4 हो जाएगा और सेकंड केस में a नॉट की वैल्यू 8 हो जाएगी. So write the series again. Any doubt? Is it clear to everybody?
Yes, sir.
Yes, sir.
Yes,
Oh,
sir.
very good. So now we are in position to take a function and write its Fourier series. Okay. So I will take a function, and before that, because I talked about the range that I am writing it for minus pi to pi or I am writing it for 0 to 2 pi. So actually the Fourier series is written for a function which is periodic or piecewise periodic. इस बात को जरा अच्छे से समझ लेना. Piecewise periodic. Okay? Like suppose you have a function like this. Okay? So you can see this is a periodic function. Yes or no? Because what is periodic function? Which repeats itself after certain interval of position or space, whatever. Okay? So this is a periodic function. But if suppose this is by nature periodic function, some sine type ki cheez hai, which itself is periodic. But you may have a function like y is equal to x. Also, if it is piecewise periodic, that means this piece of y is equal to x is repeating itself, right? So if this is happening, then also you can write the Fourier series. So this function is periodic, correct? And this function is piecewise periodic. Piecewise periodic. And what do you know about the period? Period of a function. Period of a function. So in the sense of time, we know that जैसे sun जो है, अर्थ जो है sun के around 365 days बाद वापस same path को repeat करती है. तो we can say that 365 days का वो period है. या फिर वो spin करती है 24 hours. So we can call in that sense. या फिर weeks, days, whatever they come. Okay. So period of a function is like this कि अगर मैं x में p add करूं तो I should get the same function fx, right? So actually this will happen for np. Yes or no?
Yes, sir.
Because जैसे मंडे 7 दिन बाद आता है तो 14 दिन बाद भी तो आएगा, 21 दिन बाद भी आएगा. So अगर सपोज मंडे आने की फ्रीक्वेंसी 7 है तो it will come at 1 7 2 7 1 into 7 2 into 7 3 into 7. So that's why it will become np, right? Where n is equal to 1 2 3. And so 1p 2p 3p all of them will become period, क्योंकि जो event suppose 7 days बाद हो रहा है वो event 14 days बाद भी हो रहा है. Okay, so p will be known as principal period. It will be known as principal period. Okay, because all of them will become period, so that's why p will be the principal period. So write example. Suppose मैं लूं तो I will take sine of x plus 2 pi. ये कितना बन जाएगा?
Sir, sin x.
Sin x. Okay. So what will be the value of p?
2 pi.
2 pi. Is this okay?
Yes, sir.
And ऐसा भी हो सकता है कि जैसे मान लो this is suppose 0 and this is 2 pi, right? But this may happen that ये function ऐसे जाए, ऐसे जाए, ऐसे जाए, ऐसे जाए और फिर वापस यहाँ पहुंच जाए. तो what is happening to period? So suppose this was my complete thing, 2 pi. So what is this function and what happened to the period?
Pi will be the period.
So now what is happening, you can see it is starting from here and completing it here. So this is pi. So now the period is pi. And how I will write this function as sine of? Yes? 2x?
Yes, sir.
Bolo bhai.
Yes, sir.
So if I write it sine of 2x,
Yes, sir.
then at what will happen at pi?
2 pi.
So you can see that suppose this is your function 0 and this is suppose pi, okay, and it has completed it like this. ऐसे ही हो रहा है ना? So at pi it is 0. So that means if you write it as sine of 2x, then at x is equal to pi, it will become sine of 2 pi, right? And it will become 0. Okay. So in this way, you will see that periods can change also, principal period can change. So periodic, piecewise periodic. Okay. ये बात आपको ध्यान में रखनी है कि not every function, and when I say periodic, it is not always such smooth curves. Okay. It may have like this, then this, something same should repeat. Okay. This. So
Yes, sir.
this is also a periodic function. So in real life, we don't get such smooth functions like sine and cosine. But the good part is that you can write any haphazard function in the form of sine and cosine. ये बहुत बड़ी बात है, ध्यान से सोचो कि आप किसी भी फंक्शन को which is periodic or piecewise periodic function, you can write it in the form of sine and cosine. तो चीजों को पढ़ना और समझना कितना आसान हो गया कि सिर्फ दो चीज है जिसके हेल्प से आप कोई भी फंक्शन लिख सकते हो। और ऐसा क्यों हो रहा है? क्योंकि हर फंक्शन सिर्फ 3 कैटेगरी में जा रहा है। इट इज आइदर पीरियोडिक, सॉरी, इट इज आइदर इवन, और इट इज ऑड, और इट इज नाइदर इवन नॉर ऑड। सो अगर वो ऑड है तो साइन उसको बना देगा, साइन विल मेक दैट फंक्शन। अगर वो इवन है, cosine will make that function. And if it is neither even nor odd, sine and cosine will make that function, because sine and cosine, if they come together, they will become neither even nor odd function. Okay, so right, अगर मैं 3 function लिखूं आपके सामने, suppose I write cos x, this is even. If I write sin x, this is
Odd.
odd. And if I write sin x plus cos x, if I write sin x plus cos x, it is
9.
Neither even nor odd.
so all 3 categories are ready. Okay, these are the 3 categories in which the functions will form. Okay, so now in next class I will take this discussion forward to calculate the actual Fourier series for many functions. But if you have any doubt, you can ask.